All right, here we go. Correct answers. Number 2. Silver acetate reacts with iron 3 chloride to produce silver chloride and iron acetate. Since they're all compounds, it is a double replacement reaction. Number 3 is also a double replacement. Be extra special sure that when you're translating the compounds that you are remembering to balance the charge. In this one, for example, chromium has a +3, nitrate has a -1 charge. So I need 3 nitrates to cancel out that +3. My 3 here, my little 3, is part of my nitrate package, so that does not count as the 3 subscripts that I need to counteract my +3. Don't forget your parentheses. Remember also that this little 3 on the outside of my parentheses does not get to cross the arrow because that one is not part of the poly. The one on the inside of the parentheses, however, is part of the poly, so he gets to come. Number 4 we did together. On to number 5. Number 5 is the first combustion that you have seen. It says tetracarbon monohydride reacts with oxygen gas. Anytime you see that word gas, it's part of our Brinkelhoff, so it is O2. Tetra means 4, nana means 9. Since this is a combustion reaction with my C and my H in my oxygen gas, my products can only be carbon dioxide and dihydrogen monoxide, our old buddy water. So notice we didn't have to worry about any charges or anything here. Those are the products, the end. Number 6 there is another double replacement reactions. Be extra special careful of all of your charges. Number 7, magnesium metal. That means magnesium that you just dug out of the ground, Mg. Oxygen gas, there's that word again, O2. And then magnesium oxide. Just write magnesium oxide as you would ordinarily translate that word. This too does not get to cross the arrow because it is not part of a poly. So it doesn't get to come. This is a synthesis reaction. Flipping to the last 2 on the back page. Number 8 is another combustion reaction. I know this because it's the only thing that involves covalence, and I have an organic reacting with oxygen gas. Number 9 is your first single replacement reaction. This one involves a compound and an element. The element kicks out the same charged element in the original compound. Okay, same thing down here. I have a compound plus an element, yields an element and another compound. That makes it a single replacement. Hopefully, again, this is starting to make a bit more sense. There should be enough time for at least one more section, so I will continue onwards in this video. Now we're going to talk about predicting products. So in English, if you know the beginning of a sentence, you can oftentimes finish it by predicting what comes next. Same thing in chemical sentences. Remember that each compound is written individually, charge is balanced to 0 regardless of what subscripts appear on the other side of the arrow. So, like this example here, titanium has a 3 here, no such business over here because it's not part of a poly, doesn't get to come. Same thing with the phosphate. It's got a 4 here and a nothing over here. The only subscripts that get to cross the line are subscripts that are part of a poly. So our first example is Na plus Cl. Since this is 2 elements combining into one, I know this is a synthesis reaction. Synthesis reaction means that the only thing that can appear on the right side of my action, or my arrow, is one thing from the 2 pieces. So sodium has a +1, chloride has a -1. When we combine them together to make a product, we get NaCl. The +1 from the Na and the -1 from the Cl get you to 0, so there are no subscripts necessary. So my solution to this problem is Na plus Cl yields NaCl. The second example is a bit more complicated. I have iron 3 nitrate reacting with magnesium chloride. Since I have 2 compounds reacting, this must be a double replacement, which means all ions are going to switch places. The first thing that you need to do when solving double replacements, or single replacements for that matter, is to put all of the charges in. So, I know that nitrate is a -1. From that, I can figure out iron's charge of +3. Magnesium has a 2+ charge. Chloride is a -1. Next, Let's switch the negatives to get the products. So my iron is going to go with my chlorine. My magnesium is going to go with my nitrate. And the only subscripts that get to cross the arrow are the subscripts that are parts of polys. So notice the 3 inside the parentheses is the only thing that got to cross the arrow. The 2 with the chlorine didn't get to come. The 3 on the outside of the parentheses of the nitrate didn't get to come. Last, you need to balance the charges on all compounds that you have written. So I'm going to need a subscript of a 3 to cancel out my iron plus 3, and a 2 on my nitrate to cancel out my plus 2 on my magnesium. So if you'll flip your packet over, let's do the first 2 of them together. Let's see if I can find my packet I've been writing on. Number one here, I'm going to rewrite it a little bit bigger. I have a compound reacting with an element. If you go back to your first page of your packet, we know that this is a single replacement reaction, which means that on the right side of my arrow, I'm going to have a new compound and a new element. Let's zoom this in a bit so you can see it better. There we go. Let's rewrite. I know that calcium has a 2+ charge. Sulfate has a 2- plus magnesium, who has a 2+ charge, followed by my arrow. On the other side of my arrow, I'm going to switch the positives. I cannot put the magnesium with the calcium because I cannot put 2 positives together. I have to put a positive with a negative. So my magnesium with his 2+ charge goes with his sulfate of a 2-, leaving calcium out in the cold. So now we have successfully predicted the products on a single replacement reaction. Congratulations. Let's do one more together. Number 2. I have 2 compounds reacting, makes this a double replacement. First things first, insert all of your charges. Now I'm going to switch the places of my positives. My ammonium cannot go with my silver because they are both positives, just like my chlorine cannot go with my nitrate because they are both negatives. Since the ammonium is with the chlorine on this side, when I move it over, I'm going to switch it to the nitrate. I took care of these 2 ions. Now that leaves my silver to go with my chlorine. Oh, you can't quite see that. There we go. Sorry, I'm kind of out of space here. Now we would go back and we would double check that all of my compounds in fact add up to 0. 1 minus 1 equals 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 0. If there was anything here that did not equal 0, you would have to balance those charges with subscripts. Mr. or Mrs. Substitute, please pause the video for a few minutes to allow students an opportunity to do the next 8 problems or however many there are. After the pause, I will put up the correct answers. Alright, hopefully by now you've had a chance to get through the rest of them. So let's go ahead and do the answers. Number 3, I have my CH reacting with my O2, which tells me that this is a combustion. So this one's nice and simple. I have no charges whatsoever to worry about. My products have to be H2O and water. Number 4, I have compound reacting with compound, makes this a double. First, let's put in our charges. I know sulfur is a 2-, So that's a grand total of -6 charge that I have to get rid of. Means my manganese must be a +3 to counteract that -6 charge I have over here from the sulfur. Plus PbCl4. Cl is a -1, but I have 4 of them. Grand total of -4 charge. Lead must be a +4 to counteract that. Now we're going to swap our positives. My manganese with his 3+ charge is going to go with my chlorine with his -1. That does not equal 0. I need subscripts to fix it. Plus my lead with his +4 is left with my sulfide with his -2 charge. 2 sulfides there. Last problem that I'm going to do just now is actually a typo, so you can't do this one. Never mind. Don't worry about it. If you're feeling ambitious, continue onwards. The ones on the back here are the exact same process, but you need to first translate your reactants into symbols. So I hope this is beginning to make a little bit more sense. Again, this is nothing new. We're just putting all of our names into sentences. So best of luck, be good for the sub, and I will see you tomorrow.